Spacequakes rumble near Earth, presented by Science at NASA. Rumbles without sound, auroras rain down, magnetic field shake, beware spacequake. July 26, 2010. Researchers using NASA's fleet of 5 Themis spacecraft have discovered a form of space weather that packs the punch of an earthquake and plays a key role in sparking bright northern lights. They call it the spacequake. A spacequake is a trembler in Earth's magnetic field. It is felt most strongly in Earth orbit, but it is not exclusive to space. The effects can reach all the way down to the surface of Earth itself. Magnetic reverberations have been detected at ground stations all around the globe, much like seismic detectors measure a large earthquake, says Themis principal investigator Vasilis Angelopoulos of UCLA. It's an apt analogy because the total energy in a spacequake can rival that of a magnitude 5 or 6 earthquake, according to Eugenie Panoff, Space Research Institute in Austria. Panoff is the first author of a paper reporting the results in the April 2010 issue of Geophysical Research Letters. In 2007, Themis discovered the precursors of spacequakes. The action begins in Earth's magnetic tail, which is stretched out like a windsock by the million-mile-per-hour solar wind. Sometimes the magnetotail can become so stretched and tension-filled, it snaps back like an over-torqued rubber band. Solar wind plasma trapped in the tail hurtles toward Earth. On more than one occasion, the 5 Themis spacecraft were in the line of fire when these plasma jets swept by. Clearly, the jets were going to hit Earth, but what would happen then? The fleet moved closer to the planet to find out. Now we know, says Themis project scientist David Siebeck of the Goddard Space Flight Center. Plasma jets trigger spacequake. According to Themis, the jets crash into the geomagnetic field, some 30,000 kilometers above Earth's equator. The impact sets off a rebounding process in which the incoming plasma actually bounces up and down on the reverberating magnetic field. Researchers call it repetitive flow rebuffing. It's akin to a tennis ball bouncing up and down on a carpeted floor. First bounce is a big one, followed by bounces of decreasing amplitude as energy is dissipated in the carpet. We've long suspected that something like this was happening, says Siebeck. By observing the process in situ, however, Themis has discovered something new and surprising. The surprise is plasma vortices, huge whirls of magnetized gas as wide as Earth itself, spinning on the verge of the quaking magnetic field. When plasma jets hit the inner magnetosphere, vortices with opposite sense of rotation appear and reappear on either side of the plasma jet, explains Rumi Nakamura, Space Research Institute in Austria, a co-author of the study. We believe these vortices can generate substantial electrical currents in the near-Earth environment. Acting together, vortices and spacequakes could have a significant effect on Earth. The tails of vortices may funnel particles into Earth's atmosphere, sparking auroras and making waves of ionization that disturb radio communications and GPS. By tugging on surface magnetic fields, spacequakes generate currents in the very ground we walk on. Ground current surges can have profound consequences, in extreme cases bringing down power grids over a wide area. The Great Quebec Blackout of 1989 was probably the result of such an event. After Themis discovered the jets and quakes, Joaquin Byrne of the Los Alamos National Laboratory in New Mexico conducted a computer simulation of the rebounding process. Lo and behold, vortices appeared, good accord with Themis measurements. Moreover, the simulation suggests that the rebounding process can be seen from Earth's surface in the form of ripples and whirls and auroral displays. Ground stations report just such a phenomenon. It's a complicated process, says Siebeck, but it all fits together. The work isn't finished, though. We still have a lot to learn, he adds. How big can spacequakes become? How many vortices can swirl around Earth at the same time? And how do they interact with one another? Stay tuned for answers from Themis. Vortices swirl, plasma a twirl, Richter predicts a magnitude 6. This story was written and read by Tony Phillips and presented by Science at NASA. To find more Science at NASA stories on the internet, please visit science.nasa.gov.
Famoso för därför på touchen där ni lär. Commence de touche på den där delen av det